Okay, thank you for your patience. Thank you all for waiting, and now the time has arrived to start the webinar, Optimizing Your Infrastructure Just Got Easier. And now I'd like to introduce to you Julie Chutras of Nlight Software. Take it away, Julie.
Good morning, everyone. In kicking off this morning's webinar, first of all, I'd like to thank everybody that is attending today for being an Nlight existing customer, especially on the West, and we actually have a few in Asia as well that Julie and I support. So thank you again for all of your dedication. With your feedback, we are putting together a series of webinars that will focus on our new modules and enhancements to the overall product line. So today we have Stuart Dale that is in charge of our Intel Nlight partnership from a technical point of view, and Rob Neve, of course, our founder and CTO. And so we'll be discussing today our new module, which is supported by Intel DCM. And with that being said, Rob, I'll have you kick off the webinar.
Excellent. Thank you. Jason. Just go over to the agenda. So we'll just quickly go through the agenda. So we're going to try and give you, I know this is a webinar, so it's a little bit hard to be interactive. So if you can just post your questions in the webinar, what we're trying to do is get them all at the end. So if you've got a text area there where you can put them in. But what we're going to try and do is we're going to go through, we're going to give you an overview of the Nlight and the DCM and how it joins together. We're going to take you through both products so you see how they work independently and how they work as a combined solution and the benefits of that solution. And we're going to give you an actual demo so you can see everything. And then we're going to have questions and answers, and this is really where you're going to have to try and get those questions in and post the questions, really. So to take you in a little bit, so we've got the Intel DCM console. So we've got the Intel technology, which enables you to go out there and optimize and look at exactly what's going on your Intel-based devices and devices which Stuart will go in a lot more detail around. And actually look at the energy usage, the thermals of those devices, the inlet temperatures, actually change some of the characteristics of those devices, maybe lower their set points and things on the actual devices. So we're going to go into a little bit of that. We've got the Nlight integrator, so some of you may already be familiar with the Nlight integrator. We've added this capability or technology to talk to Intel DCM Console Manager and actually bring in attributes into Nlight, use them, visualize those attributes within inside Nlight, and then also push all of that through into analytics. So we'll go through and we'll show you some of that visualization and some of how we actually do that. So visualization and what we're actually doing with the way the connector is, and you set up the frequency of the connector as always with the Nlight integrator, but we're actually bringing in, and we're going to be bringing in real-time readings of the devices. So the devices we can talk to, we can take their inlet temperatures, bring those inlet temperatures, and record those against the actual device. When we record it at the device, it enables us, as you can see on the screen here, we can visualize those in a logical row view, or when we're in the cabinet planner, we can actually see what the thermal readings are on those particular devices. What we're also able to do is bring back the real-time power of those devices. So if you say you don't have a smart power strip, or you've just got standard power strips with inside your data center that have no smartness about them, i.e. we can't read the power from those power strips, this gives you that energy and thermal readings by device. If you have branch circuits and when we can read to a cabinet, and you'll see when we get into the demo, well, we can actually start doing that. And we can combine the two pieces of information together. So we can take branch circuit information, then take us into the racks, into the devices, start seeing exactly what's going on with the devices. We can also bring back the CPU utilization and the memory power of the device as well. We can bring that and store that against the asset within inside Nlight. And all of this, everything that's coming into Nlight is then pushed through to analytics, so you can do trending and analysis and a relationship analysis. So you could look at what's the devices, who owns those devices, what business units, what their growth rate is from a space point of view or capacity point of view. But this gives you that extra dimension of actually seeing what the device is doing. So what's the utilization of that device? And Stuart's going to take us into some of that utilization piece. So over to you, Stuart.
Thank you, Rob. As Rob mentioned, my name is Stuart Dell, and I work on the Intel DCM team. I work with these partners to help enable this technology and the software with their end users. So there's 5 main things that DCM provides that we're going to be talking about today, and so I'm going to go over those really fast. As Rob already started to touch on, we're able to get real-time power and thermal data from your rack and blade servers. So what that means is we're able to talk directly to the hardware and retrieve that information. So you don't have to have intelligent PDUs and those other things acting as middlemen. And then the next thing about that is it also gives you a lot more additional data points within your rack. So now you might have 32 different data points within that rack, where before you had to previously go deploy maybe 1 temperature sensor in that rack. The next feature that DCM provides is policy-based power capping for racks and blades. So what that means is we have the ability to control how much power a server actually uses. So let's say we have a server that is currently using 500 watts of power. Well, we're able to reach out to that server and say, why don't you lower your power usage down to 300 watts of power? And then the nice thing about that feature is we're then able to aggregate it at a group level. So you're able to say, hey, this rack right here, it should never use more than, say, 15,000 watts of power. And you're able to set a guardrail, which DCM will then go and enforce among all those servers within that rack, dynamically changing their power allotment based on which servers need it and which servers don't. So that way, you never have servers that are starved for power, and you never have servers that are using a bunch of power they don't need. The next thing that DCM provides is beyond just your server power, we can also talk to network and storage devices and pull the power usage of those devices as well. So you can really get a great representation of what your actual rack or room environment power usage is. So you can see the full picture, not just your servers, but all the other devices that might be in your environment. The next one we are going to talk about, we already talked about just a little bit, which is aggregate control. And that's the ability for you to control groups of servers. So that might be you controlling a rack, you controlling a row. You can even control your entire data center full of servers and with one policy. Whatever sort of control you want, we allow you to have that sort of aggregated control either among your hierarchy or logical groups you create yourself. So say you want to group up all your servers by the different teams that own them. Well, DCM provides you that ability, so then you can manage them in that form as well. And the final thing we're going to talk about today is cross-platform support. So what DCM provides you is a just generic way to manage all the different servers in your environment. You don't have to know the different specifications of how to deal with a Dell or an HP, and you don't need to worry about what the underlying hardware is. It could be an Intel-based processor, it could be an AMD-based processor. As long as it talks these protocols that we are able to support, as we'll see in the next page, we're able to talk and control that server. So now we'll move on to the next slide where we'll start to talk about the architecture of DCM. So this is a very basic overview of the architecture of DCM. We're going to start down here at the bottom where you can see all of your rack servers and blade servers. And this kind of gives you a little representation of all the different sort of devices we're able to talk to in your environment. So here we can see Dell, HP, Cisco, IBM, all of your big OEMs that you would expect to see. Now, how we talk to all of those servers, you'll see on the next level, is we have all these different protocols or standardized protocols that we are able to talk to and communicate with these servers over. So you'll see a lot of your basic default ones like IPMI, Node Manager, iDRAC, ILO. All these different protocols are what allows us to talk to all the different servers, storage, network devices, all those pieces of equipment in your environment. And through those protocols, we're then able to expose all these different functionality out to people like Nlyte, who then incorporate our technology into their software. And we see we're able to expose monitoring, control, trending, scalability, and standardization to all of your servers. So we'll go on to the next slide where we're able to talk about some of the actual use cases that DCM enables. So here we have 5 different use cases that all of this different data that DCM is collecting, we're able to enable. So the first one, Rob already started talking about a little bit, was the ability to replace expensive smart power strips. Now that you're able to talk directly to your server and see how much power and thermal it is using, you no longer need to pay almost double the price for intelligent power strips because you can now get that same information directly from the server. So that way you're able to save about half the cost in your infrastructure alone. The next one, and we'll actually see this in the demo, is the ability to go out and identify dead or underutilized servers. And so what we do here is we're able to go look at the historical usage of that server, identify servers that aren't being utilized to their full advantage, and then show you all that information so that you can start making intelligent decisions on which ones you should decommission or combine servers so that you get the max utilization out of those devices. The next one is improve thermal profile in the data center. So this one is because you're now able to get the thermal information of all of your servers, you're able to now really generate real thermal maps of what's happening in your data center. What this allows you to do is not only know exactly what temperature your data center is running at, but be able to run it hotter and still meet your requirements. Say you have ASHRAE Class 1 requirements. Well, you're able to raise that temperature so you still meet those requirements and then save money on your cooling power. The fourth one we'll be talking about today is capacity planning. And in that one, this is really the ability to get the most out of your environment. So utilize your racks to the fullest, utilize your power and space to the fullest. And we're able to do that because we're able to show you exactly how much power your different makes and models of servers use. So you're able to fully plan and know how much actual power your server uses and not have to go off of stuff like D-rated or nameplate power when you're allocating space in your racks. And finally, DCM is able to, since we're able to measure energy by device, we're also able to help you figure out when it's the best time for you to refresh your servers, because we're able to show you the different power usage of your servers based on generation and help you find which one might be the most optimal one for running your workload on. So that's a quick recap of some of the 5 different use cases that DCM enables. So I'll now hand it back over to Rob for some more slides.
Okay, so going back on that, before we get into the demo, we just really want to reiterate some of the benefits you get with this combined solution. So really where we're able to see exactly what's going on the device, so understanding what that device is doing, whether it's utilized or whether it's not utilized, but really identifying, are we getting the maximum out of the boxes we have running in our environment? So we're able to identify targets for decommission or targets for repurposing or ghost servers. So we're able to find those. We're able to identify the temperatures down to a device in a rack. So across all of our racks suddenly become temperature readers. So we're able to see exactly what the temperature is inside our racks, and we're able to potentially run the racks slightly hotter. Or if we have areas that are hot, move some stuff around to bring the temperatures down on the other devices. So we're able to start utilizing the servers to help us get the maximum out of that environment. One of the big savings as well is if we've got normal power strips running, we don't need to go getting smart power strips. We can get the real-time values of those servers and get the power readings for those servers and save on the needs to go and actually buy the new smart power strips or actually take the downtime to implement these new power strips. So it gives you that added benefit that you don't have to go through that expense. You're able to, by understanding what the real-time value is on the box, you're able to complement. So Nlyte has the D-rated values. You're now able to take that even further by understanding, well, how do you use a DL380 inside your environment? What's its general readings for power, and what should I set the D rating for inside Nlyte going forward? And we're also able to enhance our capacity management. So our capacity management and planning and reporting and trending, we're able to see not just space, we're able to see power, and we're able to see power utilization or thermal readings by device. So that we can actually start, if we wanted to, doing cost back and charge back to groups inside the business to say, this is what you're actually using inside our environment. So with that, I think we're going to go into, I think we're on that slide now, which is where we'll start going into some demos. So back to yourself, Stuart.
Okay, Stuart, you should be all set.
Stuart, are you there? We might have lost you both. We see you visually, we can't hear you vocally.
Oh, sorry, you guys. I forgot to go off mute, so you guys can see my screen now.
Yeah.
So what we're showing you guys today is an actual instance. We're monitoring some real servers here in my environment in Sacramento. So I'm going to go through a kind of a walkthrough and talk about some of the stuff we talked about in the slides, and then kick over to Rob. So the first thing I want to point out here is we're seeing in the demo is that we've created our hierarchy. So this is where we've gone in and defined our data centers, our rooms, our rows, and our racks. And then we've assigned all of the devices to those racks. So here we can see we've done that, and then we selected one of our servers. So now we can kind of go through and select and see what you're able to see on a per device basis. So obviously the first thing you'll see here is we can see the inlet temperature of this device, and we can see the current power usage of this device being 66.2 degrees Fahrenheit, and its power usage is at 33.4 watts. As we continue down, we can then see some basic device information about this server. So we can see its IP address, the make and model of the server. Here we can see that its capabilities include power monitoring, temperature monitoring, and power control. And then down here, we're able to see any events that are happening on this server. The nice thing is, since we're talking directly to the hardware in this instance, we're able to capture any sort of hardware events that could be failed power supplies, failed memory, any sort of hardware event that happens on the server. We're able to capture and expose that to you here, and then expose that out into Nlight, so you're able to take actionable items on it. Now that we've looked at some of the basic device information, we can now start looking at the historical data that we're collecting from this server. So we can see here, this is where we're looking at the temperature, the power usage, and then the CPU, memory, and I/O utilization of this server. So if we go back and we look at some of the historical data, we can see how this server has acted over the past week, month, quarter, or even a year if we wanted. And we can see here the temperature, power, and the different OS level information that has been being collected. We can even export that out into an Excel file as well. And this is that same data that Nlight is then collecting into their software to expose in their reporting and analytics. Now that we've finished with the telemetry that we expose, we can now look at how we can control the power of these servers. So we can see it's very simple. We just come in here, we say, okay, you know what, I want this server to now use 250 watts of power. We can come in here and give it a name, and then we can specify when we want that to happen. So say this was a backup server that was only running from 1 a.m. to 5 a.m. Well, the rest of the time from 5 a.m. to 1 a.m., we could set a power cap so that this system would use the minimum amount of power possible. So we can come in here, we can set, okay, and now what will happen is DCM will reach out to that software, and it will talk to the server, and it will have it change its different internal states so that we now achieve that power reduction. The next thing I want to show you guys here is the ability to create custom events. This is where you can come in and say, I want to be notified when certain conditions are met. And these notifications can be either via email, or they can be forwarded into the Nlight software so you can manage them from there as well. So we can see we can do stuff like notification when power usage goes above or below a certain value, and the same thing with temperature-based values as well. So we can see it's very easy to set up and then be notified when we see things happen in our environment we want to be aware of. The last tab I'm going to show you guys here is where we expose some of the extra telemetry on your system. If your system supports more telemetry than just power and thermal, we're also able to collect that as well. So we can see here on these newer generations of systems, we're able to also collect the outlet temperature and the airflow, which gives us more information when we need to go do all of our reporting and analytics. Now that we can see what we can kind of do on a device basis, the nice thing is all of these same things we're able to do on anywhere on this hierarchy. So I'm able to come into this row where the device we were just looking at is, and I'm able to see all of this same information. So here I can see the temperature of my rack, the power usage versus the allocation in my rack, and the space usage versus space allocation in my rack. And I can see all of these same different values exposed now at the rack level. And the nice thing is I can even come in here at the rack level and I could set a power cap. So let's say we had a 15,000 watt fuse on this rack. Well, we could come in here and we could set us a guardrail so that we would never go over that value. And then we could even set the priority of the systems within that rack. So we could say, these guys are mission critical. Don't ever take power from them, while these guys over here are very low priority, so you can take as much power from them as you want. And by going and doing that, we've now ensured that this rack will never go above 15,000 watts and will never blow our fuse or have any sort of outage in this rack. As we can see, it's very easy to use, but it's a very strong tool as well. And the one last thing I want to talk about here is also the ability to do all of those same operations in a logical group. So you can see here I've kind of created some logical groups for all my different OEMs worth of servers, but this could just as easily be HR, QA, and all the different departments in my group that I maybe want to be able to monitor and see how much resources they're using in my environment. So we can see all the same level of operations exposed. And this is just another way that you can control your servers in addition to the hierarchical management of the devices. So now that we've talked a little bit about the data we're able to collect and the control we're able to expose over these servers, the next thing we want to look at is some of the analytics that we're able to do and provide to you to help you make automated and intelligent decisions in your environment. So the first one of those we talked about is the ability to identify ghost or underutilized servers. So what this part of the tool does is it allows you to go analyze the historical usage of your servers and find servers that are being underutilized. As we can see in the results here, all of these servers listed had less than 10% utilized, and their average utilization was far under 10%, and they were rarely fully utilized at 99%. And here we can finally see the savings that we would get if we were to consolidate those servers. So here we can see just in these first 4 servers that have pretty much no utilization for the historical time we've been watching them, if we were to consolidate them, that would save us over just under 100 kilowatts of power per week. So as you can see, it's an easy tool to start going out and finding those servers in your environment that aren't being utilized. The second part of this tool that can be very useful is we're also able to identify usage patterns of your servers. So as you can see here, we've identified with these 6 servers that they have very specific time patterns where they're being used, and the rest of the time they're not being used at all. So here we can see that server 2 and 3 are being utilized from basically 10 p.m. until 9 a.m., while these servers down here are only being utilized from about 8 a.m. to about 6 p.m. So we can easily see if we were to consolidate these servers on the applications running onto these servers on one server, then we would see constant usage throughout the entire day, and we wouldn't have those underutilized servers in our environment anymore. So the next piece of analytics that we're going to talk about, as I flip to the new tab, is what we call server power characteristics. And this is really the ability to see, based on the different makes and models in your environment, what the actual power usage of your servers are. This can be very helpful, as we talked about, when you're doing stuff like rack capacity planning, and you're able to use the actual power usage of the server and not have to rely on the nameplate or derated power of the server. So as you can see here, we have all the different makes and models of servers in our environment, and we can see the actual power usage they run in. So I know if I have a Dell PowerEdge C5200 in my environment, it uses anywhere from 45 to 242 watts of power, while an Intel S4600 will use anywhere from 45 to 497 watts of power. Obviously, now I know when I want to go, say I want to go provision 4 of these S4600s in my environment, I know I need to allocate 2,000 watts of power, because that's what the actual power usage these devices have used. The other part where we can start seeing additional benefits from this information is when we're able to compare systems that might be running the same workload. So let's say we have this Intel S2600 right here that's running the same workload as our Dell C1100. Well, I know if these two systems are running the same workload, it's cheaper for me to be running my workload on the C1100 because my max power usage is almost 200 watts less than on my S2600. So just with those simple, with that simple ability, we're now able to figure out which servers are the most optimal ones to run our workload on in our environment. And so this is just kind of some of the basic ways you can start using that information, and it gets a lot more detailed when we start exposing that out to Nlyte, and they then start using that in their reports. We have one last piece of analytics that we're going to be talking about today, and then I'm going to pass it over to Rob for his demo. And here what we're talking about is the ability to start predicting how much power your environment is using. So here what we do is we have the ability to tie in both your OS level CPU, memory, and I/O information along with your hardware information such as power and thermal. And once we've collected that information, we're able to go in and then make models where we can start predicting your power usage based on your workload. It's a very simple process. All we need to do is come in here, define our workload, or give our name to our model, come in here and pick a server who's collected enough samples for us to do it, and then we can come in here and do it. So here we can see we already have one defined, so we'll go in here with this one. So here we can see that we've made a model for a Canoe Pass server. And so if we start typing in the different metrics, we can then see how much power that server will use. So let's say we would use the metrics if we were to run something like spec power, which would use 94% of the CPU and just about 1,200 I/O a second. Well, we know in that case then, this server running that workload will use 331 watts of power. And we're now able to predict that and allocate that in our environment since we know that's what we're going to be using. Now we can also see, say we were to run a workload, something more like I/O meter, which would run at 4% CPU, but a much higher I/O, something around 93 million I/O a second. We can then see in that case our CPU usage is, our power usage is much lower at only 85 watts of power. So as you can see, this is a very helpful tool for you to be able to start predicting how much power you're going to need to allocate in your environment based on the different workloads that you run and use in your environment. And with that, it kind of wraps up the DCM part of the demo, and I will now hand it over to Rob.
Cheers, Trip. There we go. There. All right. So what we'll do is we'll start from here. So we'll start on the floor plan, and then we'll drill down to some assets, and we'll start seeing how we're utilizing different levels of information and how you can start using that information to see exactly what's going on in the environment, how it relates to other areas of Nlyte. So on the floor plan, if we're talking to branch circuits or we're talking to a smart power strip that doesn't have outlet level readings, we can bring in the information and we can start showing it at the floor plan level. So we can start showing you what the energy is that's being used in those areas. If we drill down and we look in this row, we can start seeing, as this loads out, there we go. We can start seeing what's going on from a device point of view for the power. Let's look at temperature first. For the temperature within inside, so we can get the inlet temperature readings of each device, so we can actually get what they're reading and how that's affecting each one of the devices within inside a row. So we've turned the whole row, if you like, into sets of readers, giving us that across the data center or across the row view of temperature reading or inlet temperatures. So if, a prime example of a use case for that would be if we were in a colo environment where we've got an agreement with the colo to give us, say, a inlet temperature or a cooling temperature per device, we could see if they're fulfilling that requirement. So we'd be able to see that there and then across our actual devices. From a power point of view, we're able to ask the same question as well. It's just like show me the power per device and see what each device is actually drawing. And if we drill down into an actual device itself, let's do that. Go to the rack. When we're talking into DCM, we're actually bringing back the information. We're putting it on the real-time metrics within inside Nlyte against the device. So we're reading in the inlets or the real-time values that are coming into the Nlyte system. They're being stored against the devices, tracked against the devices, and all the attributes that we're bringing back in, so the CPU and the memory as well will be also tracked inside there. From an analytics point of view, again, all of this is pushed through into Nlyte Analytics, so we're able to do analysis. So if we go in and actually look in, we're able to bring back, we have a number of standard reports in here where you'll start seeing that association of information. You'll see a business group, you can see the devices, you'll be able to read the real-time values that we're getting back against each device. If you wanted to, you could attribute a cost to this. So if you wanted to charge a particular business unit or have a cost for a business unit for its power usage within inside the data center for its services or its devices, you'd be able to say, right, these are your devices, this is what your energy cost is, and then Nlyte will be able to produce a standard report that you could give to that customer for their actual energy usage, as well as all the trending and capacity information you'd be able to get across from those devices. Okay? So that was a demonstration today that we've kind of taken you through, which is where we've seen Intel DCM, how we were able to actually take control of servers, as well as read metrics from servers, how we're able to bring that information into Nlyte, and how we're able to use that information in Nlyte visually, and then how we're able to push that visualization of that information into analytics, and then you can build and complement with the related information in Nlyte to do other areas of capacity management or chargeback or showback within inside your organization. So with that, I think we've kind of covered everything that we wanted to cover today. Now it's really your questions and if we can answer those. So back to yourself, Jess. Back to the slide deck.
Will do. Sorry. Great. So let's see, at this point, let me see if there's any questions here. Oh, we do have one question. So I'm going to throw it out to both of you and take a time to answer the question here. So how can we use an existing power strips in our racks to gather power and cooling data in a dashboard through Nlyte?
So you've got other smart, I guess, if the smart power strips, so you have an existing power strip inside your data center today, and it's a smart power strip. If you use the SNMP from Nlyte's integrator, and you put the correct MIB information into the integrator, we'll be able to bring back those real-time values and pass those into the power strip within inside the rack. We'll then aggregate that and push that up into the rack so you'll be able to visualize it on the floor plan. If you've got a smart power strip reading that's just power strip level, or sum of a power strip. If you have outlet readings within inside the power strip, we can read the outlet information as long as it's defined within the MIB profile when we're reading. We can store and we can bring that back to the assets. If you don't have that level of reading, you only have the power strip or the branch circuit, then we can then complement that information with DCM. We can actually start giving you the device readings. So it's really, we can fit whatever you have. So if you've got smart down to outlet, we can read it. If you don't have outlet, we can still get you it because we can talk through with the DCM and give you the device readings.
Great. Thank you, Rob. Any other questions out there from the audience? It appears the presentation was awesome. Very detailed. And no other any other questions at this moment? Anyone else? All right, well, I'll toss it over to you, Rob and Stuart, for any closing remarks. And with that, if anything else, we can just go from there.
Yeah, I mean, I will say this, that if you have any questions, I know it's a bit difficult, you watch the kind of slides and everything else and you go through demos. If there are questions or if there is anything further you want to know about how we're doing this integration, the benefits of this integration, and also if there's something you saw today within the DCM or you've read on something on DCM and you have other questions, let us know. And we can work with Stuart, we can get you an answer back. And yeah, that's really it from my side.
Yeah. Stuart, any closing remarks?
No, if you had questions or you would like further demos, please just reach out to Julie. I work very closely with her, and she can definitely set it up and get any of your question answers, or we can do in-depth demos to follow up and show you how this would really work with Nlyte in your environment. So please feel free to reach out to me or her.
Great. Thank you, Stuart. And with that, we'd like to conclude today's webinar. Thank you to both Stuart and Rob for their time, and of course, thank you for your time for joining on this webinar. For more information, please contact either Julie or Rob or Stuart, and we'll get you some more information. Thanks again, and have a great day.